Hello everybody, my name is Halo. Welcome to this video series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this video we're doing problem 233A, which is called perfect permutation. This is a very tricky problem to understand just because how the problem is phrased, but nevertheless if we try to break this down and just formulate this problem by itself, the solution is quite simple only. Let us go ahead and see how this problem is solved. So let's just go ahead and read this problem once before we attempt to solve it. And reading this and understanding this problem is basically 99% of the task. The solution is not that much complex. It's just how you understand this problem. Okay. So first things first, what are they saying? What is a permutation? A permutation is nothing but a series of numbers. Okay. A sequence of numbers containing n distinct positive integers, okay, and each of them does not exceed n. That's it. Okay, let's denote the ith element of a permutation as pi. Let's just break this down first. What is a permutation? Any set of numbers. Let's say there's a permutation of 4, length 4, that is n is equal to 4. So this can be either 1 2 3 4 because they are distinct positive integers, nothing is repeating, and they don't exceed this number 4. Okay, so a permutation here, this can also be something like 4 3 2 1, yeah, or 1 3 4 2, any combination of that, but all the numbers from 1 to n will be present there. Okay, so that is what they mean by a permutation. And one more thing what they're saying is, let's take this as a permutation. This particular element for this permutation p will be called as p of I, which is nothing but p of 1, which is equal to 1. Okay, in this particular case p of 1 is equal to 4. Okay, this I is nothing but 1 2 3 4, that is the element in the particular permutation. So I hope you're able to understand what we mean by pi. Pi is nothing but the ith element of a permutation. Okay, and that's it. So we call n the size of the permutation. That is something that was given to us before itself. Okay, next, what are we saying? We say that Nicholas adores permutations. Okay, he likes some permutations more than others. Sure, buddy. He calls these permutations perfect. What are perfect permutations, you may ask? A perfect permutation is such permutation p that for any I in 1 to n. Okay, so I is inclusive of 1 and n, the following equations hold. And they've given a set of 2 equations, and let's just go ahead and type what these equations are. So first things first, p of I should be equal to I, and p of I should not be equal to I. Okay, okay, let's just kind of deconstruct this, but then before that, let's just go ahead and complete the question. Nicholas asks you to print any perfect permutation for size n given that n. So there might be multiple perfect permutations, but we need to find a perfect permutation that is kind of general, because that's what the solution is asking for, and give us any perfect permutation for of size n given n. Okay, so what can we break this down? First things first, why is this condition given? Okay, you need to find that out. Okay, see, let's assume that a permutation pi is equal to I. Let's assume the contrary of this. That means p of pi will be equal to I. This is nothing but I. So p of I should be equal to I. So anything that is 1 2 3 4 for n is equal to 4 will be a perfect permutation. They don't want that. So this case is not accepted. They want you to do somewhere where this p of I is not equal to I. Okay, in that case you have to find out how you're going to go through all of this. Okay, so some things to keep in mind. Another technique, if you are new to Codeforces or competitive programming in general, is sometimes you can get your answers from the sample input or sample output given as well. Okay, and this might be a bit tricky because sometimes Codeforces they'll give you cases which does not lead to anything. They're like false leads. Okay, and this question is a primary example for that, because they're saying if there does not exist a combination, or let's just say there does not exist a perfect permutation, you should output -1. And obviously they've given a case, but they've given a case for 1. Obviously for 1 there is no other case, because there is only 1. This is what you can do. This is the only permutation possible, and in this particular case p of I will not be, this p of I will be equal to I, so this will automatically be invalid. Okay, so this part may be useless, not exactly. And the second part, there's only two types of permutations with the numbers 2 and 1. Either you can do 1 2 or you can do 2 1, correct? So in 1 2, some things to keep in mind is p of I should be equal to I. So this case is false. So obviously this is not a valid permutation. This means, let's check here. P of I is obviously not equal to I, but what they're saying, what is P of I here? I is 1, okay? So P of 1 is given as 2. What is this here? P of 2 is given as 1. Can you notice something here? This 1 right here, can I replace it with this part? So we can say P of 2 is nothing but 2. Similarly, we can say P of 1 is equal to 1, because this 2 can be replaced by P of 1, correct? And that is what they're saying here. So this is a valid case. Okay, so this might have some information for us. And then we have the next case. Okay, so let us break this down a bit further and solve this for the third input. So we have N4 and we have this particular set here, 2 1 4 and 3. Okay, so let's just take, see, there are 4, there might be a lot of cases here. Let us just consider this particular case. I think this is the most useful piece of clue for us, because there exists only 2 particular permutations here. So the other permutation must be how we are going to be figuring out the logic. Here there might be multiple permutation, where there might be multiple permutations which are perfect as well. But for the sake of this, let's just go ahead and work. So we know these two, anything with these two numbers are a perfect permutation. Okay, now let us go ahead and do the same for these two. Okay, so what this is nothing but P of 3, correct? And what is this? This is nothing but P of 4. So we know P of 4 is equal to 3. So I can replace this 3 with P of 4. Okay, so this is nothing but this value 4 right here. And this satisfied, this is also satisfied. Similarly, this can be replaced by P of 3 is equal to 3. So this is also satisfied. So this also is a perfect permutation which something follows this same logic. Okay, so what is that logic? Let us go ahead and formulate a solution for this. Let us solve this mathematically. Okay, let's say P of I is given as I. Okay, because that's the condition we need to check, where P of I is not equal to I, correct? So we know that P of I is not equal to I. Okay, so let us assume, okay, P of I equal to some random value j. Okay, we have this equation here. Okay, now bear with me here. Let me go ahead and apply this particular case in here. Okay, so what do I get now? Okay, so instead of P of I, I'm going to apply j. So P of j, right, which is nothing but P of I, okay, will be equal to I. 1 second. So you're telling me if I apply P of I equal to j and P of j is equal to I for any set of I comma j, this will be true. This perfect sequence will be true. Yes. Let us go and see if that is possible. Let's take this 1 2 3 4 case itself. Okay, so instead of 2 1 4 3, let me take some random values. So this is P of 1, correct? So let's say I take P of 1 as 3. That means P of 3 should be 1. Okay, if P of I is j, P of j should be I. Okay, so I can take this as 4 and 3 1 2. Okay, so let us see if is this a perfect permutation or not. Okay, so first things first, P of 1 is 3, correct? And P of 1, that is P of 3 is 1, correct? Similarly here, this is nothing but P of 2 4, and this is nothing but P of 4, which is P of 2, which is 2. So this works. So in any case, let me just erase all of this over here, and let me just write this down a bit better. Apply for I comma j, okay, P of I is equal to j and P of j is equal to I. Okay, there are various methods of applying it. There are so many ways to do it, but yeah, you need to kind of figure out which is the best way. I'll tell you one way how to do this. Okay, so first things first, let us take two pairs, because obviously this means there needs to be a pair I comma j. Okay, so always this only works with even numbers, because you always need, for every I comma j, you need both I and j. So no matter how many pairs you're putting, you need pairs. That means for any n which is odd, such a perfect sequence cannot exist, because for some value of I, for example, let's say I have 1, 2, 3, 4 and 5, we can take this as ij, obviously this as some ij, but where is the j for this? We can only have I. So that means for any odd value, the answer will be -1. That is, it does not exist. That is why there is -1 here. Okay, great. What if even? Let us take the very base case. Okay, so what we are saying, let's say n is equal to 5 or n is equal to 6 here. Let me take one case. I will take 2, 1, okay, 4, 3, 6, 5. This still works, but because for this is I, this is j, this is the same, this is the same. P of I is equal to j, P of j is equal to I. I am just going to swap the first and second elements, and I'll keep repeating this for each pair. And that is just one way to approach this. You can try whatever way you want. This, I think, is the easiest method. This is the easiest way, because P of I, what is P of I? This is P of 3, correct? And this is 4. Similarly, P of 4 is nothing but 3. So we need to create a list where this order is followed. Okay, so for any value, you put that particular value and then that value -1, and then you increase this particular value by 2. Okay, so there will be 2, 1, 4, 3, 6, 5, and I'll keep going. Okay, so that is it for this solution. Let us go ahead and look at the code. If you guys understand how to do this now, you can go ahead and do it in Python. If you guys don't, let's look at the code now. Okay, so first things first, let us go ahead and take n as an int. So there will be int of input, and we'll say if n %2 is equal to 1, checking if n is odd. Okay, in that case, what we can do, we can go ahead and print -1. Okay, what do we do else? Else nothing will do. As we discussed over here, we'll start from 2. We'll do I, we'll append to the answer I comma I -1 and add this by 2 and keep repeating it until it is less than n. Okay, that is our answer here. So how do we do that? Simple. So first things first, I mean not less than n, less than or equal to n. I'm sorry. So let us create a for loop, and let's just create an answer list, and let us create a for loop for I in range 2. We'll start from 2 to n plus 1. That means n will obviously be included, but anything more than n will not be included. Okay, and we'll go ahead and increase the step value to 2. What does this mean is, instead of going from 1, 2, 3, 4, it'll directly go, it'll skip 2 places. It'll skip 1, 3, 5, 7 like that. But since we're starting with 2, it'll go 2, 4, 6, 8, 10 like that. Now let us go ahead and extend this particular list by the elements of I comma I -1. So we're extending this answer list with 2 elements. We are appending 2 elements to the end of it, and those will be in this particular format. Okay, so now that once we are done with all of this, we can just go ahead and print this particular list. And how do you do that? If you just go ahead and put answer, this will come as a string format with this bracket, something like this. But we need to print out space separated integers. This is where a concept, if you guys didn't know, we're going to be dealing something called unzipping a list. Okay, and this is a built-in thing in Python. Instead of putting the list's name, put a asterisk in front of it. What this will do is, it will print the contents of the list as space separated integers. Okay, so if we go ahead and run this, you can see all these test cases passed. Let me just go ahead and submit this code as well to show you guys that this code works. So yeah, I mean that is this problem. I spent a very long time trying to understand, wrap my head around what is this P of I. But yeah, that's the solution. It's a very simple solution. If you guys have some different solutions, let me know that down in the comments. If you guys have any question, let me know that also down in the comments. You guys can help each other out. I will try my best to clear your doubts and read through all the comments. I really hope this video helped you. As you can see, this solution got accepted. If this video helped you, hit that like button. We have a lot more Codeforces videos. You can go check that out as well. Comment if you want something to be improved, or if you have some feedback, or if I can improve my teaching. Thank you so much for watching. I'll see you in the next video. Until then, bye.